Hello and welcome to History of Atomic Theory Part 2, Attack of the Electrons. Now, some background observations. At this point in history, we have learned about spectrums, which is a series of colored lines that are emitted from an element when it's zapped with electricity. Each element has a unique set of lines. As we see here, the brighter colors are the colors that each element has. So hydrogen has a red, kind of a cyan, and then a darker purple. Helium has a lot more lines. Oxygen has more still. The amount of lines is not really important. It's that each one is unique to it. So this little line of green for oxygen, oxygen is the only element that will have this line. While the others seem to have a line, if you look closer, they will be slightly different. Now, another background information. There's a weird light trick that scientists were finding around the 1900s. When a piece of metal is charged with electricity, electrons will jump off with certain colors of light as shine on it. Now, this was called the photoelectric effect. So, when we shine the light, we can see that electrons start jumping up, but if they don't have enough energy, they're not going to leave. Now, this seems very reasonable until they start messing with the color. And at some point, the color of light will stop that. Now, most scientists thought that it was the intensity of the light, how bright the light is. The brighter we shine the light, we should have more electrons jumping. But there is some color that for some reason, color was the deciding factor. You had to be a certain wavelength before it would jump. And scientists were trying to figure out why this was. What was so important about the color when all the scientists thought it would be the intensity that would be the big factor. Einstein figured out that the color indicates energy. Remember Roy G. Biv, red is low energy, violet is high energy. So when we're looking at this, the reason the color is so important is because we're shining different energy onto this. So, where we had left off with atomic theory, Rutherford and Bohr had determined an atom was a concentrated nucleus made up of protons and neutrons, and the electrons are on the outside. What we're going to focus on in this lesson is how are the electrons organized? What are they doing on the outside? So Bohr's model said that the electrons move fast enough to stay in orbit, so they won't be spinning off into the next atom. They'll stay in orbit, and they're going to change orbits by changing energy. And he brought in Einstein's ideas about light and energy, which meant that when the electrons are changing energy, they're going to do so by absorbing light or emitting light. Now, if all the orbits are possible, this meant that all the colors should be possible. However, we don't see that. Remember, all we see are certain colors coming off the atom. So, Bohr had to adjust his model. He said electrons are only allowed to be in certain orbits, but he could not explain why they could only be in certain orbits. He could do the math that would very precisely explain why there was this color and this color and this color for hydrogen, but he couldn't explain why those numbers were there. Now, there was a young grad student in France named de Broglie. He wrote his PhD thesis, and he used Einstein's idea that light was both wave and particle. And he thought, what if this applied to electrons? If that was true, then the orbits that form a standing wave could be the reason why only certain orbits are allowed. Most of his professors thought he was crazy. He wrote a letter to Einstein, and when Einstein read it, he thought, this explains everything, and de Broglie got a Nobel Prize for his PhD thesis. Now, a standing wave is kind of a weird thing. This is what it looks like with string. So, this is a device where this is an oscillator. They can adjust the frequency with that device. And so a standing wave is when you have these special frequencies where you get these standing patterns. So one of the main thing is on a standing wave is there's these nodes. So only certain frequencies will have this. There's only one frequency that will set up this one node system. Now, this kind of gives a good overview of what we've gone through on our models. So we have all this light particles moving through, and if atoms were like originally thought, indestructible, all the light would not interact with it, they just bounce off and nothing would happen. Then we went to Thomson's plum pudding model, where we'd have the electron moving around a little bit, but not a whole lot. Bohr's model of orbits explained a lot of things. We can see that the electrons are jumping levels, and everything works. As we said, the big problem with this model was that he couldn't explain why these dashed lines were the only ones allowed. De Broglie figured it out by his standing wave models. Only the ones that make a standing wave in these circles, that's why these circles are allowed, is because they're the ones that allow a standing wave to form. You can see how there's nice wiggling when we're at these things. Now, the next scientist is Schrodinger, and he came up with an even wilder theory, that the electrons can't really be said to be in any one spot. So we can't say that there are these little circles orbiting in a circle. We can't even say that there's these waves going around. They are regions of probability, and this is what the regions look like. And Schrodinger is the one that did the math to figure out these energy levels, and this is what we'll be talking about later. And this is what we're going to use. It's going to be called electron configuration. So when the electrons are on each of these things, these are all going to be energy levels, and then these are the sublevels inside, and it's going to be different patterns of this cloud. So Einstein started a field of physics called quantum mechanics. It makes very accurate predictions, but also shows how weird the particles behave on the atomic level. One thing that is very strange is that we can't know where a particle is exactly. As I said, Schrodinger's model developed quantum mechanics for atoms. Orbitals are what we have now instead of orbits. They are areas where the electron has a 90% chance of being at any given time.